Hello everyone and welcome to this presentation on dictionaries and sets in Python. This presentation is part of my Python assignment focusing on two key built-in types, dictionaries and sets. I am Arpit Singh and in today's presentation I'll guide you through their definitions, internal workings, operations and practical use cases. Let's get started. Here's an overview of what we'll be covering in this presentation. We'll begin with a quick review of main collection types in Python that includes lists, tuples, dictionaries, and sets. Then we will explore how dictionaries and sets are defined and used. We will dive deeper into their operations and methods, look at how they compare with each other, discuss performance like hashing and time complexity, and wrap up with advanced features such as comprehensions. Finally, we'll summarize key takeaways. Slide 3. Python provides several built-in data structures to work with collection of data. Lists are ordered and mutable. That means you can change them after creation. Tuples are also ordered but immutable. Once created, they cannot be modified. Dictionaries represent mappings. They store key value pairs and allow fast lookups. Sets are ordered collection that store only unique elements. In this presentation, we'll focus specifically on dictionaries, which map unique keys to values, and sets, which are unique collection of individual elements. A dictionary is an associative array or a mapping structure that stores data in form of key value pair. Each key in dictionary must be unique and hashable, which typically means it must be immutable, like strings and numbers. In Python, dictionaries can be defined using curly braces or a dict constructor. Keys are followed by a colon, then their corresponding values. For example, inventory dictionary has mapped apple to 10, banana to 5, and orange to 7. This dictionary maps fruit names to their respective quantities. You can think of it like a table where each row is a key value entry and behind the scenes it's managed using a hash table. This ensures that operations like lookup and insertion on a dictionary are very fast. We look at some basic operations performed on a dictionary. Lookup. Lookup is accessing values using square brackets like dict key. For instance, D dict A will return value associated with key A. If it if the key doesn't exist, it raises a key error. Insertion or updation. You can add or update key value pair using dict new key and assigning that to a value. Deletion. To move an entry, you use del keyword and followed by dict and key. Membership test. You can test if a key is present or not in a dictionary by key in dict. It returns a boolean value, true or false. Iteration. We can loop over dictionary by using for key in dict to loop over keys of a dictionary. And we can also use dict.items to iterate over key value pairs. Here are some common dictionary methods. Dict.keys returns all the keys in a tuple. Dict.values returns all the values in a tuple. Dict.items returns key value pairs of a dictionary. Dict.get and its parameters are key and a default value. Returns value of the key, and if the key does not exist in the dictionary, the default value gets returned. It is helpful to avoid errors. Dict.update merges two dictionaries together and dict.clear removes all item from the dictionary. Now we see how dictionaries work. Dictionary use hash tables for storage. That's why there is a hash index which helps in fast lookups, insertion and deletion. It usually uses constant times or big O of 1 time complexity. When we insert a key, Python computes a hash of the key using hash function. This hash determines where in memory the value should be stored. Instead of searching through all entries, Python jumps directly to the calculated location, which makes operations very efficient. There are some rules that must be followed while creating a dictionaries. All keys must be unique and keys must be immutable so that they can be hashed and won't change after insertion. Moving to slide number 8, we see sets, definition, and creation. A set is an unordered collection of unique elements. It doesn't store key value pairs, just values, and each value must be unique and hashable. You can create sets using curly braces or set constructor. We can also convert other Python data types into set and it only stores unique values so duplicate values will be removed. Also, like dictionaries keys, set elements must be immutable. We can use numbers, strings, or tuples, but not lists or dictionaries. In slide 9, we see some set operations. Some mathematical operations can be performed on sets, like membership test X in set returns true or false based on if X is present in set or not. Union, it can be performed in set which combines element from both sides and duplicates element are stored only one time. In intersection returns common element from both set. Different difference A minus B specifies only elements in A that are not present in B. Symmetric difference return elements either A or B but not on both. We see some set methods and comprehensions in slide. Set.add adds an element to a set. Set.remove removes an element but raises error if element is missing. Set.discards remove an element safely without error. Even if the set doesn't contain the element, the syntax doesn't generate an error. Set.pop removes an element from stack and returns it to the called variable. Set.clear empties the entire set, creating a empty set. In slide 11, we see quick comparison between common built-in data types. Lists are mutable, ordered, and contain duplicates, but doesn't contain key value pairs. Tuples are immutable, ordered, and contain duplicates, but it also doesn't contain key value pair. Set are mutable, but doesn't but set are not ordered, doesn't contain duplicates, and doesn't contain key value pairs. Dictionary are mutable. Dictionaries are also ordered and cannot contain duplicates. Keys are only created once in a dictionary, and dictionary contain key value pairs. We see in this comparison between dictionaries and sets in slide 12. Although dictionaries and sets are quite different, they both use hash table internally. A dictionary stores key value pairs, and a set only stores keys. You can think of a set as a dictionary where all values are same. Often, so a dictionary be used when you need to map keys to values, and a set should be used when you only care about unique elements. As print b dot keys return keys of a dictionary in set. So if we check type of key view, it returns a set as the dict keys behave like a set. Now finally we see summary of this presentation. We see that dictionary are mutable, unordered mapping of unique key values, and sets are mutable, unordered collection of unique elements. Use dictionary when you need fast lookup by key and sets when you need to check membership or perform set operations. Both structure are optimized for performance using hash tables, giving big O of 1 average case X. By understanding when and how to use dictionaries and sets, you can write cleaner, faster, and more efficient Python code. This concludes the presentation on dictionaries and sets in Python. Thank you for reviewing the material. If you have any further question, please feel free to reach out for clarification or discussion. Thank you.